In this video, we'll be converting repeating decimals to fractions, and we'll look at more complex examples. You had yesterday simple examples such as 0.6, 2.3, when it was the repetition or the pattern of one number or two numbers or even three, but you didn't have any non-repetitive digits. So today we want to look at examples such as 0.8 not repeating, but then from then on will be 333 repeating, or 0.1 not repeating and 36, 36, 36, 36 repeating. So there is a combination of non-repeating and then after ongoing 5, and then 41 not repeating and 666 going on from there. This is repeating but mixed decimals, so they are a little bit more complex in converting to fraction. I'm going to divide the page into two and have the conversion on one side and checking on the other. So I'm going to start with an example. 0.8 not repeating, 3 is the repetition or the pattern. In this situation, the 8, which is not repeating, is very important. That is one not repeating or not repetitive decimal. In order to begin, we are going to have the fraction, and on the numerator we have 83, and we will subtract the not repeating number 8. Before, if we had two digits, we placed the fraction over 99, but that not repetitive one digit will be subtracting 19. So listen one more time. If you have one digit before the repetition, you subtract 19. If you have one digit before the repetition, you subtract 19. So before we had just like this. If 83 was repetitive altogether, that would have been 83 over 99, and we would simplify. Now we have a non-repetitive number, which is 8, so we're going to subtract it on the numerator, 83 minus 8. On the denominator, we have 99, and because we have one repetitive, one number that is not repeating, we subtract 19. You'll follow the pattern in a few examples. (83 minus 8 will be 75. 99 minus 9, 90. And then we can simplify by dividing by 5. 75 and 90 can be both divided by 5. That would be 15 over 18. And then we can divide by 3. And that would be 5/6. So the fraction 5/6 in simplest form should be my decimal 0.8 not repeating and 3 repeating from there. I'm going to check on this side. So let's check this answer. Is this really true? We have 5 on the inside of division symbol, and I want to place a few zeros there. We're dividing by 6. 6 does not go into 5, but it goes into 58 times. 6 times 8, 48. Bring down a 0. 6 goes into 20 now, 3 times, which is 18. When you subtract, you have 2 again. Bring down a 0. 6 goes into 23 times, which is 18. And then subtract, you have a 2. Bring down a 0, and that will go on and on and on. So we have 0.8, and then the repetition of the 3, the pattern, which is exactly the same decimal that we started with. Let's see another example to observe the pattern and how to go through the steps. So for example, we have 0.7 and 5 is the only pattern ongoing. 5, 5, 5, 5, 5. 7 is the first digit. 5, 5, 5, 5 keeps going on forever. So the line is about 5 only. To start, you want to have 75 over 99. Now, we have one non-repetitive digit, which on the numerator we subtract minus 7. On the denominator, we subtract 1, 9. If we have one digit before the repetition, you subtract 1, 9. So on the numerator, you subtract the digit itself. On the denominator, you subtract 1, 9. Subtraction, 75 minus 7, 68. 99 minus 9 is 90. And then we can divide those by 2 in order to simplify and have 34 over 45. Let's get this instant feedback on the calculator to check. 34 divided by, turn it on, 34 divided by 45 would be 7 after the decimal and then ongoing 5s. And since the calculator doesn't have ongoing space, it rounds it up at the last digit. But without the rounding, that would be ... Let's go on. So 7 and 5 repetition. To check if this was an item on the test, you would set up a division of 34 and put a few zeros behind the decimal and divide by 45. 45 doesn't go into 34, but it goes into 340 7 times. (45) times 7, 315. Subtract. Bring down a 0. That'll be 250. 250 divided by 45 would be 5 times. It's 5 times. So 5 times 45 is 225. Subtract. And this is my 25 again. Bring down a 0. That'll be 250. 45 times 5 is 225. Subtract, and again is 25. So that repetition of 5 will be observed after the 7, just like the decimal we started with. Let's look at another example. What if as 0.125, 5 being the repetition. The 1 and the 2 are the two digits that are not repeating. So the way you would start, you would put 125 and 999. Okay? But then, since not 1, 2, and 5 all together are repeating, just the 5 is repeating, on the numerator you subtract the 12. Now you have two digits that don't repeat, so you would subtract from the denominator 2 9s, or 99. So if it's only one digit not repeating, from the denominator we subtract 1 9. If it's two non-repeating digits, from the denominator we subtract 2 9s. Let's see if that works. 125 minus 12 will be 113. And 999 minus 99 is 900. Let's see if that works. So in the calculator, 113 divided by 900. Okay, 113 divided by 900. 0 point, the 12 was not repeating, and then 5, 5, 5, 5, 5 keeps going on. Again, the 6 we ignore at the end because it's just rounded up for the space limitation, but it's exactly the same decimal we had before. To check, you would put 113.000 and divide that by 900. $900 doesn't go into 113, but it goes into 1,000 one time. So we have 900 to subtract. Putting down the 0. 900 goes into 2,300 two times, which is like 2 times 9, 18, with 2 zeros. $900 goes into 5,000, like 9 would go into 50, 5 times, which is 45, with 2 zeros. And here's the 500 again. So if I add another 0, the 9 into 50, or 900 into 5,000, would go 5 times again, which is just like 5 times 9, 45, with 2 zeros. And we subtract, and here goes the 500 again. And that will keep repeating forever and ever. What if the example is given? I'm running out of space here, so I'll move on to the next page. If you have more room, you can continue here, but it will take me a little bit more room here. So I'm moving on to the next page for the next example. Split the page in half.